about the standard form of a quadratic today. So we're going to start by doing what is standard form, or what does standard form look like. So we're going to write that up here first. We're going to write it in function notation. So f of x equals ax squared plus bx plus c. This is considered standard form for the quadratic function. Chances are you've seen this before in Algebra 1. Most Algebra 1 classes were able to talk about standard form. Usually in the end of second semester you talk about quadratics. Okay. Let's talk first, what's the same as vertex form, or what's different from vertex form? So let's talk similarities first, and if you want to flip back in your notes to what vertex form looks like. Is there anything about these two equations that's the same? Damon? Okay, excellent. The a is in front of the x squared. I totally agree. And that's actually one of the things, we'll see it again tomorrow with intercept form. A is always in the equation of the quadratic. And what's nice about a, it always does the same thing. So this a is responsible for stretch and shrink, and it's also responsible for reflecting our parabola. So we can tell if the a is positive in standard form, that the parabola opens up. If the a is negative in standard form, the parabola opens down. So it does the same things that a has always done. So a is the same. I totally agree. Is there any other similarity that you'd like to point out? Okay, differences. What's different about this form than our vertex form? Jackson?
There's two x's.
Oh, that's an excellent one. Instead of having, like, in vertex form, when you look at it, you have that one group of parentheses and you have the x in the x minus h in the parentheses. But in the whole equation, there's only one x. And now we get to see two x's. So we have an x squared term and we have an x term. Those two terms are not like terms, so we'll never be able to combine them into one. Okay, they'll always be two separate terms. Okay, so there's two x's. That's a big difference from vertex form. Anything else different? How about the change in letters? Right? I mean, you're missing HK, aren't you? H and K have not been replaced, but they're out of the picture, and now we have B and C. So if I take away H and K, that means we no longer know what the vertex is. Because in vertex form, when I wanted you to find the vertex, we just grabbed HK, where H always looked like the opposite. Okay. Now we have to do some algebraic work to find our vertex. So I'm going to give you instructions for how to find your vertex. First, I'm going to give you instructions that are just like, in our own words, what are the steps we would take, and then I'll write out what a mathematician might say is the vertex for the standard form quadratic function. So, in plain terms, to find the vertex, the very first thing you're going to do is find the x-coordinate. I am going to give you the tool that you will use to find the x-coordinate, and that tool is x equals the opposite of b over 2a. So this is something you can put in your list of things to study. Got to know this. Okay. Notice when I say that, I say opposite of b as opposed to negative b. That way you know whatever the sign of b is, whether it's positive or negative, when you put it into this little tool right here, you're going to change its sign. So if b was positive, it's going to become negative. If the original b was negative, it's going to become positive. Okay, so I always call it the opposite of b over 2a. You'll get B and A from your standard form. Okay, so you'll just pull those numbers out. Step 2. Find the y coordinate. When you have a function and you know what x is, how do you normally find y? If I have y equals ax squared plus bx plus c, and I know what x is, how do I get that y?
Plug in x.
Yeah, plug in x. Substitute x for the value, and then figure out what y is. Okay? So we're going to substitute negative b over 2a in for x. Well, remember in this one, f of x is a fancy way to write y. So we're writing it in that function notation, but that is saying y equals. Now, I say substitute in that negative b over 2a. You'll have already done opposite of b over 2a, and it will be just a number. So if you find out that the opposite of b over 2a is 3, all you have to do is take 3 and plug it in. Okay. So it looks like you're doing lots of algebra there, but all your algebra was done in step 1. And you're just now working with a regular number. You're not really working with that opposite of b over 2a anymore. Okay. So those are the two directions to find the vertex. We'll do an example here in just a minute so you can see how that works. I'm going to write out what a mathematician might say the vertex is as an ordered pair. So remember yesterday when we were working in vertex form, we could just say HK. In standard form, our H is what we did in step 1 for the x coordinate. So the opposite of b over 2a. That's our x coordinate. And then we want to have the y coordinate be whatever we get when we substitute that back in. So we're going to use function notation, and we're going to say that the y is your f of the opposite of b over 2a. So this is saying x is the opposite of b over 2a. Y is whatever you get when you plug opposite of b over 2a back into the function. If you don't like the way that this looks, that's okay. You can follow the 2 steps on the right that we started with. But I want you to at least see that in case you see it online in a video or in your textbook or next year in Algebra 3. Okay, you might see that representation again. It's saying the things that we're saying to the right of it. Now, vertex takes a little bit of work. I'm willing to admit that. But once you find the vertex, the axis of symmetry is done, right? So the axis of symmetry yesterday in vertex form was always x equals h. Today, our h has been replaced with opposite of b over 2a. So our axis of symmetry is just the opposite of b over 2a. Or sorry, x equals the opposite of b over 2a. Again, at that point, you're probably not really even doing the math for it because you've already found the vertex, so you already know what that number is. And I'll show you that in the example. There's one other thing I'm going to show you here. And it's one of the nice things about standard form of a quadratic is there's an extra point you can find very easily. And that's the y-intercept. So remember, y-intercepts are where our graphs cross the y-axis. In order to be on the y-axis, which is your vertical axis, you cannot move left or right. Because if you go left or right, you're no longer on the y-axis. So every y-intercept has an x coordinate of 0, so that you're going 0 left and 0 right, and you're staying right on the y-axis. Well, think about what would happen if we were to plug 0 in to our standard form at the very top. If I did a times 0 squared plus b times 0, and then plus c, these first two terms are going to get multiplied by 0 every single time. No matter what a and b are, they'll always reduce to 0. So every time you plug 0 in, you always get out c. So whatever constant term is being added on the back of the quadratic function in standard form, whatever that c value is that doesn't have an x, that's automatically the y-intercept. That only works in standard form. It does not work for vertex form in K. Okay? We're going to do an example. We're going to put all this to work. Sometimes, you know, I give you all this information and then it doesn't make sense until we see it with numbers. So we're going to look at an example. We're going to do the example f of x equals 3x squared minus 6x plus 1. And we want to label its vertex. We want to find its axis of symmetry. And we're going to add to this, we're going to find the y-intercept as well. Just like we did yesterday, if you're feeling a little bit like you're not certain how everything works in a function, feel free to write the standard form either above or below your current f of x. So I'm going to write f of x equals ax squared plus bx plus c. And as long as you've got everything in the right order, you'll immediately know what a, b, and c are. Okay? A is 3, b must be negative 6, and c is 1. So that when I want to find the vertex, and I go back to my notes where it says do x equals the opposite of b over 2a, I can pick out what b and a are. So I always do the numerator. What is the opposite of b?
6.
Positive 6. And you'll leave the x's out. So a, b, and c are just their coefficients. We will never write x's in this. Then we're going to divide it by 2 times a, which a is 3. And then do the multiplication on the bottom, so that's 6 over 6, which means the x-coordinate of my vertex is 1. Okay. If I know the x-coordinate of my vertex, I can find the y-coordinate of my vertex by plugging that value in. So step 2 to finding vertex, evaluate f of the opposite of b over 2a, which we have found to be 1. So I'm going to take 1, and I'm going to plug it in everywhere I see x in the function. So I'll get 3 times 1 squared minus 6 times 1 plus 1. Does anybody have any questions on where I got that? Now, you have to work this out with order of operations. Okay. If you use a calculator, notice that I put parentheses around whatever I substitute in. That's super important if you're using a calculator, when you're working with a negative number. Without those parentheses, your calculator may give you a wrong answer, but it's because you put it in wrong. Okay, so you would need the parentheses for the calculator. If you're going to go without a calculator, you have to follow order of operations, which, and this very first term, this is the most important piece. You have to do the exponent first and then multiply. Okay, so in PEMDAS, exponents come before multiplication. So I'm going to do 1 squared first. What's 1 squared? Just 1. And then multiply 3 times 1 to get 3. Notice that if I did that out of order, if I multiplied first 3 times 1, I'd get 3, and then I'd square it and get 9, which will give me a totally different answer. So you have to do the exponent first. Minus 6 times 1 is minus 6, plus 1. So negative 3 minus 6 is negative 3, plus 1 is negative 2. And there's my vertex, 1, negative 2. It takes a little bit of work in the beginning to get your vertex. I'll admit that. You got to do the algebra. But after you get the vertex, axis of symmetry and y-intercept will come along very nicely. So we still want to do axis of symmetry here. The axis of symmetry we're always going to write as the equation of a vertical line, so x equals. And then remember back from yesterday, the axis of symmetry is always the x-coordinate of your vertex. Okay, or what we said in the notes, the axis of symmetry is x equals the opposite of b over 2a, which we have already figured out is 1. So I have my axis of symmetry. And then the last thing I want to do is find my y-intercept. My y-intercept always comes in the form 0, comma c. So then you just look back at your original function. What number is c? And there I found vertex, axis of symmetry, and y-intercept. I put it right here. Sorry. There's the vertex. There's my axis of symmetry. And here's my y-intercept. So as I was working, once I found x was 1, I created an ordered pair. And then I plugged x, or 1 in for x to find y, and I added that to my ordered pair for my vertex. Now this question doesn't ask you to graph, but it's worth mentioning, okay, that by doing this work, we can make a really nice graph for our quadratic function. We know we have a vertex at 1, negative 2, so I could go right 1 and down 2. That's where my axis of symmetry passes through, x equals positive 1. And then what's really nice about this is I have this extra point, 0, 1. So I can plot out my y-intercept at positive 1. And then using the symmetry of the parabola, I can reflect that over the line of symmetry, and I get a nice parabola shape. If you compare that parabola back to A, since A was positive, the parabola should open up. It does. Since A was 3, it should be stretched vertically. It is. Instead of going up 1 over 1 to the next point, we have to go up 3 over 1 to the next point. So I've got that stretch there. So it works out really nice for graphing. Now I need you guys to practice so that you can find vertex, axis of symmetry, y-intercept. I'm going to come around the room. I'm going to look at your work. I'm going to peer over your shoulder, so don't get nervous when I'm doing that. I want to see what everybody has. So show your work, so if you do something wrong, I can find your mistake and alert you to that. But I would like for you to do, I'm going to have you do P of x. So we're going to skip H of x. And I'd like you to find the vertex, axis of symmetry, and add the y-intercept for P of x. And I'm going to come around and check your work and see how you're doing. So we'll just quickly talk about how this will work out. Remember, if you're having trouble, write out the ax squared plus bx plus c so that you can match everything appropriately. So we want to do the vertex, which is x equals the opposite of b, so positive 8, divided by 2 times a, which is negative 2. We'll get 8 divided by negative 4, and then we come up with negative 2 for the x-coordinate of our vertex. As I went around the room, you have to be really careful with your signs there. Okay, so pay attention to positives or negatives. That can make a difference. After you find out that x is equal to negative 2, plug that back in. I guess this is p of x, so we want to do p of negative 2. And we'll plug in negative 2 everywhere we see x. Again, a reminder, if you're going to use a calculator here, you need to include those parentheses. That would be very important. If you're not using a calculator, your order of operations is important, so that we do the exponent first. When you square this number, it will always be positive. If you square a positive, it'll be positive. If you square a negative times a negative will also be positive. So we're going to get a positive 4, and then multiply it by the negative 2 for negative 8. Negative 8 times negative 2 is positive 16, and then plus 1, so we end up with 9. There's our vertex. There's a lot of algebra, there's a lot of computation there. You have to be diligent in your work. Please show me your work, like I complimented you on your chapter 1 tests. Show all that work so that if you get positive 2 for your x-coordinate, but you do everything else right, I can give you credit for that and take off for your sign error. Okay, so be aware of that. Axis of symmetry is just x equals the x-coordinate of my vertex, so x equals negative 2. I don't have to do any computation once I have my vertex. And then my y-intercept is 0 and c, and the value of c is 1. So I have all 3 pieces there. Are there any questions that I can answer? To get 9, so this is finding the y-coordinate of my vertex. I had done the opposite of b over 2a to get the x. And anytime you know x and want to find y, you take that and you plug it in. So I went back up to p of x, and you can see I'm plugging negative 2 in everywhere I see x. Okay, so
I don't really take that random either. Like it's just like that's random.
okay, so are we in agreement that at this stage we're saying x is negative 2?
Yeah.
We're all okay with that. Okay. So this function up here, remember, if you don't like function notation, p of x is just a fancy way to write y. So this is really y equals negative 2x squared minus 8x plus 1. Are you okay with that? Okay. So then, if x equals 2, and y equals negative 2x squared minus 8x plus 1, how can you find y?
Isn't that what you're doing down here though? So why are you equaling it to 9? Like 9, I don't understand at all.
Would you agree that I should substitute it in?
Yeah.
Which is what I did over here?
Yeah.
And then I'm just doing order of operations. So like 4 times negative 2 is negative 8. Negative 8 times negative 2 is 16. And then plus 1. And then negative 8 plus 16 is 8.
So you're just putting 9 on the end because you didn't want it to go down.
Oh, yeah. Okay. That's what is troubling us?
Yeah.
Okay, yeah. You can write it vertically or horizontally. It wouldn't matter. Have I answered your question, Chastity?
Yes.
Okay. So, if if you really dislike that function notation, you can get around it by substituting y, where you see the function notation. If the p of -2 is causing you trouble, that's y. That's the value of p when x equals -2. That's all it says. Any other questions that I could clarify? Okay, we have only a few minutes left, so I'm not going to work out this whole problem, but this was similar to a problem that we did yesterday, where you have to identify if you have a maximum or a minimum. You have to do domain and range, and you have to say when the graph is increasing and decreasing. And if you'll look back at your example from yesterday, in order to answer all of these questions, we had to find the vertex. So yesterday, it was really easy for us to find the vertex because we were working with h and k. Here, we're going to have to do a little bit of grunt work to find the vertex right away so that we know what is the min or max x and y values. So find the vertex. You can tell if it's a minimum or a maximum. Remember how Damon said that A was the same? Since it's positive 1/2 in front, we know that the graph would open up, so that means I'm going to have a minimum value at my vertex. Okay, so you can do that sort of thought process there. And then once you know the vertex, you can answer the range and the increasing and the decreasing intervals. So your homework assignment is here.